This one's going to be a little different. We're not taking apart a house that's actually broken. We're taking apart a house that's actually functional. This house fully functions. It's called the Withered Mansion. Here. There's no animatronics. It's just lights and sound. You got flashing lights to imitate the lightning. You got the green and orange and ultraviolet LEDs. The reason we're taking it apart is it was a special request. Somebody has one of these houses that doesn't function. Only half of it lights up. No lightning sounds, no sounds in general. No flashing lights. It's just the orange and some of the UV lights light up. So we're going to take it apart. And since I have to take it apart to troubleshoot, might as well film it so if anybody else has this mansion, try and take it apart to repair it yourself. So of course the first thing, like any, or most Lemax, you gotta take the bottom off. Which sometimes it comes off easy and sometimes it don't. What I plan to do for troubleshooting is figure out, whoops, apparently I broke the glue for this front window. That's what's in your front window. Try and get the glare off. Interesting little picture. You can see it's just hot glued on, so that's not too big of a deal. We'll just glue it back in. It's just a piece of paper that apparently has been sitting out for so long that the glue they use to laminate it on has come off. What we'll do for troubleshooting is we're going to test the power junctions on the board, see what the powers are, try and check the capacitance. Just electronic troubleshooting that can be used on other houses where the circuit boards aren't working to see if you can find if you have a dead component. There's the glue for the controller part of the board. It's stuck to the back. So yeah. This house was made in 2014, so after 6 years of owning it in a state that's usually pretty dry for the majority of the year, all the glues have broken down. On the very bottom, before I start tearing it apart, there's where that picture and table went, and then this is what I'm going to be pulling out. But just to ensure nothing has power, even though the switch is off. Whoop, just broke the cat. That's what they make super glue for. I'm going to pull the power to ensure nothing has power beyond the switch. There's the circuit board right behind the speaker. And there's the rat's nest of wires. And what I did notice about seeing pictures from the person that has a bad house that's not functional, this is a very intricate circuit board. There's a lot of little components. And it is just hot glued in and staked. There's two plastic stakes and there's a bead of hot glue. So technically, if the hot glue was dried out, I could pop it off. Here we go. That's one. Two. Speaker is held on with a 2-pin Molex connector. We're just going to pop that bad boy off, set it out of the way. Generally, if a circuit board is bad, if it's one of these small components, you can replace them in most cases. If this is bad, this little blob chip, let me give it a little bit more light. Hopefully it's not swamping out the camera too much. This green circuit board with this black circle, it's generally called a blob chip. If that is bad, there is no repair of the circuit board. On the back, as you can see, the only thing on the top here is another capacitor. To check a capacitor, visually check to see if it's damaged. look at the capacitor, and the top of it will have a line or a triangle or an X. That's so if the capacitor fails, it'll swell, and instead of it exploding, it bulges the top. I don't think I have any bad ones lying around. I usually just toss them when I fix them. So you can check your capacitors of that style visually, and then the smaller capacitors, like these little guys. Some of these are capacitors, some are resistors. We'll have to use a magnifying glass to tell you what's what. You can't tell if they're blown without using a multimeter with a capacitor setting or a capacitor meter. I own a capacitor meter. That's what this is. Nanofarads and microfarads, and then millihenries for inductors. This is a specialty piece of equipment. This one comes from webtronics.com. They're generally not that cheap. This one was at a pawn shop. I picked it up for 45 bucks. So, price is subjective. It might be cheap to one and expensive to the other. It's a special type of meter. You do not want to try and put power to this meter because you will fry it. So it's a very select use meter. Right now, I'm trying to find my magnifying glass. There it is. Start reading some of these numbers. Looking at the rows, on this bank right here, you have the first one says it's R1, it's blank, which means resistor, or excuse me, R13. The next one says R12, R11, R10. So these right here, the first three are resistors, the next two are capacitors, and the last one's a resistor. So we're going to check them and see if the capacitors are good and if the resistors are good. You have to do all this with no power. Try and check a resistor with power. You can damage the equipment, not always. The capacitor, though, you risk really damaging something, especially on these small blob chip style things. I'm surprised mine works. This capacitor's been getting real hot. The capacitor on here is called C8, and it has changed colors and burned the symbol off the top to tell me what the capacitance is. It's usually never a good sign. Oh yeah, I unplugged it. My houses are generally not on all year round. They do stay set up all year, but they don't have them running constantly. This chip right here, trying to read it, it's probably a timing chip for the lights. Print is really dark. These three components right here, hopefully you can still see them. Those are transistors. Whoever soldered the circuit board on this capacitor, they kind of screwed it up at an angle. It still makes connection, it's just not square. So the resistors are 1,200 ohms, and there's one in here for 394 ohms. So we got some basic resistors, low resistance because of the low power. It's only 4.5 volts. So I'm going to set this onto 200 nanofarads. I need to prop it just a hair so you guys can see it and I can see it too. There you go. I'm going to check the capacitor that's discolored and see what it says. Just reset it. There we go. Alright, I'm going to change it to 2 microfarads. So this capacitor is approximately 0.9 microfarads. And what I really want to do is check the incoming power where it goes through. There's a chance it blew one of the incoming power capacitors, which incoming power is this red and black wire right here. The red wire comes over here to this jumper, which goes to probably the solid lights, because it goes right up this ribbon cable of 5, which is light blue, white, gray, yellow, and light green. And they go in, oh sorry, that would be this. That would be your on-off switch and your volume. So after it goes through there, she comes back and goes through this capacitor here that says C2. So let's check the capacitance of C2. .85 microfarads. After C2, it runs to the yellow wires right here, which the yellow wires are the solid lights. There, there, yeah, and the one over here. You can see them inside. So after it makes its way around, it then goes to a resistor, which goes to the white wires, the first bundle, which is 3, which are, what is it? They're resistive returns. And what else we got? This chip is also connected after the capacitor. Pretty much everything on this side of the board right here is connected to this first capacitor. So, where's the next section? Right here, goes down. On the back of a circuit board or the front, depending on what kind of board it is, there's going to be tracks. And you have a dark green section which does not conduct any power, and then you have a lighter green section which is actually copper. You can see the copper where the coating that makes it green didn't cover, for components that were optional or for a different sound effect circuit board. So this capacitor is also junctioned over to this capacitor on the top. This one on the top has printing on it, and I can tell you says it is a 16 volt 100 microfarad. So we'll set this for 200 microfarad, and we'll see if it's within tolerance. Tolerance is generally 10%. $95 microfarad. 10% would be 90 to 110. So this capacitor is still good. Be careful with capacitors. Even if you unplug it, they can still hold a charge, and it's only 4 volts, but you can still get a tingle when you work on bigger items. They hold more power, and they can hurt. So once it goes through this capacitor, it then goes off through the resistors, which then goes up to the bank for the blob chip. So I'm going to check the other 1, 2, 3, 4, 5, 6 capacitors. On this second bank of components right here, it's a resistor, capacitor, 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 resistor, resistor. You have a capacitor here and a capacitor here. So we're just going to check there just to try and get a baseline for everybody. This one is also 95 microfarads. which is C8. C3 apparently that's too high of a setting. Still too high of a setting. Apparently this one's a nano. This one's 12.8 nanofarads. C5, 92 nanofarads. C6, there is no C4 on this row, if you're wondering why I jumped the number. 93.3 nanofarads. And C7 apparently is a higher. Maybe it's not. Just not getting a good connection. 95 nanofarads again. C4 is just to the side of the chip. It's actually connected to pin number 5 on the chip. And that one is still too high. 8 microfarads. I think that covers all the capacitors. Again, this is just to give you a baseline. If you have this and your circuit board's not working correctly and you want to verify you don't have a bad component, you can get surface mount capacitors and resistors to replace them, or you can get that style and solder it to the pads and have it hang off. I've done that myself when I didn't feel like buying a tube of these little guys, because they're not sold individually. They're generally sold in tubes of like 100. So unless you're doing a lot of things that require 100 capacitors, it's not worth it. The big capacitors, the bigger style like that, you can get them in packs of 2 or 5. You don't have to get a big old tube of them. I'm now going to check resistance. Get you a baseline on all the different resistors. So we're going to use a different multimeter. This multimeter does AC, DC power. It does ohms, which is your resistance. It checks diodes, which would they be normal diodes or light emitting diodes. And then you can check amperage. It doesn't have a capacitance setting, which is why I own several different meters. So I have it set on ohms right now. OL means open line, no resistance, no load. So we're going to check all the resistors. I'm going to start on this top bank with R12. R12 is 0.99 kiloohms, or it's probably just a 1 megohm within 10%. And the one next to it, which is R11, is the same. .99 kiloohms for R10. Again, there's going to be 1 megohm within its resistance. The one next to it actually says ROSC. Doesn't have a number. That one is 382 kiloohms, 383 kiloohms. R1 is 197 ohms. So it's probably a 200, and yeah, the top says it's a 200 ohm resistor. So again, most resistors have a 1, 5, or 10% resistance. I'm going to go to this second bank right here, which this is resistor 32. just because it says 32 doesn't mean there's actually 32 on the board. This one is 1 megohm or 0.98 kiloohms. And we're going to go over to the middle section, which is resistor 3, which is probably going to be the same. No. Resistor 3 is 9 kiloohms or 9,000 ohms. Resistor 2, 9 kiloohms. Resistor 40. That one's going to be a little harder to get to, but I think I can do it. There we go. 327 ohms. Resistor 41. They're underneath these bundles of wire. I'm trying to get a good connection on the pads. That one is 33 ohms. The reason it's beeping is because it thinks it's a short. I have it on a tone setting. You can turn that off on most of them. Next is resistor 42, which is these black wire bundle. See if I can get in there and get a connection. Here we go. This one is also 33 ohms. Resistor 43 is non-existent, just like resistor 13. Capacitor 11 and diode number 2. Diode number 1. Those are all non-existent components on this board. Resistor 23, 22, and 23 and 22 are non-existent. So is 24, 25, and 26. That's these copper pads at the bottom that have nothing. But these white wires are hooked up to resistor 21, so let's check that one for everyone. Let's see if we can get a good connection. Here we go. This one is 75 ohms. And let's see, is there anything else hiding under these bundles of wires? Capacitor 10 is non-existent. And the component next to it, which is either a resistor or capacitor, is also non-existent. This diode is non-existent. There's no name, the ink is smeared. And then the next one over, which is this black rectangle right here, is a diode. It says diode 3 or D3. And then that's what that symbol is. It looks like an arrow that's pointing at a flat spot. It says it takes 674 millivolts to pass current. Now I'm going to check it backwards. And in reverse, it says it's 482 millivolts. Diodes are generally like a door that only open one way. Some diodes, like Zener's, can take current in both directions. On an LED, you'll get an open, and then you'll get a closed. Let me see if I have one lying here I can show y'all. I'll turn the light off a little bit because generally they'll glow a little. And this is for everybody who doesn't do electricity. On a diode, you have a long lead and a short lead. Long lead is hot, short lead is ground. Also on a diode there's a flat spot on the side, even on these little guys in here. And that's to help tell you it's ground in case both leads are the same length. So what I'm going to do is put the negative on the short and then the positive on the long. It says this takes 1.77 volts to start lighting up, and I don't know if you can see it in the camera, but if I touch it, it might be a little glow. And if I reverse it and put the positive lead on the ground and it says 0 or open line. That's because this is a one-way diode. It can't take power the wrong direction. Which is why on some things, if you plug the power in backwards, if it doesn't have a capacitor or a different diode to stop it, you can blow your LEDs. So that can be bad. Let's turn the lights back on. Make sure I checked all the components. The only thing I can't check are the transistors 7, 6, and 5. So, what we're going to do is now we're going to check the voltage. So I'm going to change this to DC, volts DC. We're going to plug the house back in, which right there. I'm not going to plug the speaker in for the noise. You see it lights up, it's flashing. So now what I want to do is I'm going to reference everything to ground. So to make life easy, I'm just going to stick my ground lead in the negative, which is the black wire. And if I stick the positive, we'll say on the bottom here, it says I'm getting 4.6 volts coming in from the Lemax AC adapter. So we're going to go to the first component. We follow the hot around, which we know the first component is this. So I should have 4.6. Then the return is going to be this top one, which is 0.4 volts, which is the signal for the chip. Can you still see that? Good. And then the next one down is also a return, which is 4.6 or 4.56. There's always going to be a little drop because this is a resistor. It's a potentiometer for your volume. And the next return is nothing. And the last one is also nothing. So I'm going to turn it up and see if those actually have power. 4.1 millivolts, and this one has 0.4 volts. So it works on how far this wheel is spun. Looking at it from the bottom, going from the top to the bottom or left to right with the circuit board in your left hand. Across the capacitor, do this carefully without damaging anything. At 4.5 volts on the, make sure that's tight, on the capacitor, which is the C2. So following the track for the incoming power, go around. So we're going to check power on each one of the components. So on the resistor, 0.4 volts, which is R1, capacitor C8, no voltage, ROSC, 1.42 volts on the top and 456 on the bottom. So we're just going to check the tops, I believe, because the tops will be the resistance coming out. Never mind. The R1 is 0.7 volts on the bottom, or excuse me, R10, not R1. R11 is 0.6, 0.7, same thing, it's bouncing because I bet you it's for the volume or the lights. The next resistor, which is R12, there we go. Can't get a good connection. It is bouncing, it's 2 to 3 volts. Second row, R2. $5 millivolts, R3. $7 millivolts. These can be really small because it's these right here are controlling the chip. The chip doesn't require as much power. C3 is going to be the same at 5 millivolts. Get 5.5 millivolts. C5 0.6 volts. C6, which on my circuit board is the one that's cocked at an angle, is 2 volts. C7, 2 volts. Resistor 32, full 4.5 volts. I'm going to drop down to the next section, which is R4 and R5. R5 is 2 volts, R4 is 2 volts. Again, we're doing this just to give people who have this. C4 is 0.6 volts to make sure they have good power if they're experiencing issues with this house. There is no repair. This is just to determine if you have a desolderable component that can be replaced. D3, which is diode 3, which is just below the chip to the left. We got 4.57 volts on one side and pretty much no power, 3 millivolts on the other. So it's working in its one direction. Alright, the resistors in here are going to be a little bit harder. R40, 0.9 to 1.7 because it's probably the flashing lights. If it's flashing, of course, it can't give you a solid number. 1.6 volts on R41. R42 is 2.3. R43 doesn't exist. And on the big bundle of wires at the bottom, we got 4.5 volts of power. Most likely they're just hot wired in, so they all have hot power, and then they're resisted on the return, which would be the ground, and then the flashing lights go through the different components, the timer chip, so on, to make them flash. And then at the very bottom here, where the white wires next to the yellow wires, these 3 white wires, is resistor 21, which is the last resistor. And we have, if I can get to it, 2.55 volts. So there's the power coming in, causing everything to do its job. This way you can test everything on this little circuit board and then screw it back or glue it back in. Sorry, there's no screws on this, so it's a glue-in board. Hopefully this helps. That way, if you have this piece currently or plan to get it and you start having malfunctions, don't plug in the wrong adapter. That can fry some of these small components. Don't get it wet. Common sense, but things do happen out of our control. Have a hot glue gun handy, since everything in these things are hot glued. And I wouldn't recommend using anything like Gorilla Glue or Super Glue on those, because if you do, you'll have a harder time in the future of taking it apart, since they bond harder. But just to show that the sound still works, I'll plug it in. Yep. So you can see there's stuff on the top here as well for symbols for things that don't pertain to this unit. You have a C9, which is another big capacitor, a little bit bigger than this one, and you have P1, which could be another chip bank based on the pins, or it could be a multi-resistor bank. I'm going to say it's probably a chip bank. And then you have a plug right here that says DY1 or DY2. Oh, there's glue on the edge of it. DY1. Not sure. I'm going to say it's probably a diode, but on the back side it shows it would be capacitor jumped across. I call it capacitor 11. And then right here, for no apparent reason I can see, based on the tracks, whatever would go here jumps across and have a capacitor right here. That capacitor would run around and then connect to the volume just by tracing the tracks. Also, there would be a diode en route. So it shows it would be a capacitor and two different diodes facing in opposite directions to the power knob. So I don't know if this component was to control some other feature that maybe ran through the speaker, maybe it's a secondary sound chip, or it was a generic board they used in other houses where they just switched the components around, since there is an entire bank of blank components on the bottom. But hopefully this helps. This circuit board is B8, and this was manufactured 9/11 of 2013. So if you have another board that you pull out of one of your houses that has B8, you might have similar components, maybe similar resistances and capacitances, but hopefully this helps. It's again not going to be a very interesting video unless you are trying to work on this yourself. If this chip is bad, which I have to look it up since I have no idea what this chip is for, I'm assuming it's a timing chip, it might be replaceable by cross-referencing the numbers on the top. There are actually numbers printed on it, and they're just really hard to see because they're not backfilled with a white or silver color. They're just etched into the chip. If this is bad, which is the blob chip, it's garbage, unfortunately. There is no repair. You have to find another house that's a replacement of the one you have, or is busted up, but the soundboard and the light board still works, and then make sure you rehook all these rat's nest of wires back into the correct places. So hopefully this helps the one who needs the information on this, and helps anybody in the future on how to check components against a functional house to see if they blew a component. Sometimes if it's a small component, you can see it'll be popped or burnt, like my one capacitor is discolored, which means it's probably going to go. Something on the house will fail to work, and then I'll have to pull it apart and go from there. As far as looking at the stuff, you can use a standard magnifying glass like Sherlock Holmes style. I use something like this, so it folds up. I can see normally, fold it back down. Just makes it easier. I can still have both hands on the project, and I don't have to worry about trying to finagle things with one hand. What's nice about these is I got one visual size, and then there's a fold down inside which amplifies it again, so I can get even closer to what I want to see. So, but that's it for this one. This is the 2014 Lemax Withered Mansion inspection on how to check the circuit board for reference of capacitance, resistance, diode voltage, and voltage of power from the actual unit that goes through it from your on switch to the return path to your plug. Now I get to whip out the hot glue gun, glue all this back on, re-glue on the cat that accidentally broke off, and glue in the dining room or foyer setup with the cat in the wingback chair, and probably the narrowest door I've ever seen, and Grandma Bones in the background. So hopefully it helps. Until the next video, have a good one.